applying on the building. There is no problem with the property applied. You can able to assign the property. Please answer to you. Yes to yes or no to no.
Yes.
Okay. Vibhuti,
Yes, sir.
there is no problem assigning with the property.
No, sir.
You are able to assign property.
Yes, sir.
Okay. MJ, you too. MJ.
Yes, sir.
Okay. Now, what was the loads? Please don't mute yourself. Give answer. MJ.
Uh, Seismic load,
Okay. Seismic load.
wind load,
Wind load. Yes.
and then wall load.
Wall.
Yes.
Okay.
Dead load, live load.
Achha, the wall load is different from the dead load or live load. Yes, MJ.
Pardon, sir.
The wall load, it's different from
Yes.
the live and dead load.
Yes.
Okay. Okay. Now the next. MJ described the 4 categories, right?
Yes.
What was that?
Dead load, live load, superimposed load,
What? Okay.
wind
Okay.
loads,
Yes. And fourth one?
seismic load.
Yes. But you mentioned the fifth one, superimposed load. What was that?
Yeah.
What was that?
Superimposed loads are nothing but wall load.
Vibhuti,
Yes, sir.
what is the dead load?
It is a static load. It does not move.
Okay. So a dead load, it is a category or a load applied on building.
Load applied in building.
That's not category.
Okay.
Okay. Sabha,
Yes, sir.
Vibhuti's answer is correct or wrong?
Like, exact. So dead load is what, like wall load, whatever it is,
Okay.
the self load in the building.
Okay. But my question is, you give answer right, but my question is, dead load is a category load or a load applied on building? You understand my question?
Yeah.
Okay. So give answer.
So like live load will be load applied on the building, right? So
Or dead load?
extra load rather than the building,
No, dear, you don't
what?
understand my question.
Yeah.
My question is not this. My question
Okay.
is, what is the load or which type of load applied in the dead load? My question is this. I cleared you, these are the load categories, but not loads. Wind and seismic are the loads, but live and your dead load is not load.
Yeah.
But in this category, loads are defined.
Okay.
Understand? MJ, any question or any question mark? MJ,
Yes, sir.
understand my answer?
Yes, sir.
Okay. I explained deeply when I applied, but this is only introduction, right? So
Yes.
you know what is the UDL, uniform distributed load? What is linear varying load, right? What
Point
is
load.
point load? You know
Yes, sir.
what was that? You don't mention in the load category when I ask you. Vibhuti, you answer first.
Driving vehicle, we used to apply that, but in structure,
Okay, your answer finished.
yes, sir.
Dinesh.
UDL sorry,
Okay, no problem.
uniformly, may I?
Yeah, sure.
Uniformly distributed load is load at an equal intervals.
Okay,
Load applied on equal intervals.
okay,
Then the point load is load at when the load is applied at a particular point.
okay.
Then
Linear varying.
variable distance. So the load will be at it will be not uniform. Like
Okay,
the distance will be not uniform.
very good. You described it beautifully. But these loads are come under the dead load or live load, or in both.
Then live loads.
Not in dead load.
Uh,
Okay. Now this you are familiar with these terms, right?
Yes.
Right, Vibhuti,
Yeah.
Dinesh, MJ, Sabha.
Yes.
Yes.
Now, talking about the dead load. Okay,
Yes.
you give answer. The self weight of a building is the dead load, right?
yeah.
Okay, I agreed. But we consider Vibhuti answered the dead load is a static load which is not changed or 24 into 7 applied on the building, right?
Yeah.
Agreed?
Yeah.
I'm also agreed with her, right?
Yeah.
Okay. So which type of loads in the building which is applied 24 into 7? Which type of load or which element are the load considered on the building? Understand my question?
So repeat again.
Okay. My question is which elements of your building is considered as the dead load?
Structural member of the building, then slab.
This okay. So structural member of a building, beam and column, is considered in the self weight because we cannot define the load for that. Okay, whatever the load weight of your structure is coming, itself it is a self weight.
Self weight, yes.
Yes or no?
Yeah.
But other than this, what was the dead load?
Slab.
Slab. Okay, very good. And any other?
Flooring.
Flooring is comes in the slab, dear. Slab is also
Marble.
floor.
Wall.
Wall. Very good. Wall. Okay. The wall load. Talking about the wall. Okay.
Yes.
Which type of load is applied by the load? Whether it is a linear bearing, UDL, or point load on a member.
UDL.
Sure.
Yes.
Okay. Very good answer. And what type of load applied by the slab?
UDL.
Not UDL.
Huh?
Not UDL.
Point load.
No, not point load also.
Uniformly bearing.
Yes, uniformly linear bearing load. Okay.
Yes.
Okay. Now I'm going to explain how to apply the loads. Right. Go to the general. Click on general tab. Right. Okay. First we this is the second. I opened the wrong figure. This is your figure. Right. Okay. For the applying for the load, we go to the general. Right. In the general, we applied the property in support yesterday, right? But today we are discussing about the load and definition. Click on load and definition here. And you have another option to go to the command and go to the loading. And this is your primary loads, right? So this window is open while clicking on the primary load. Okay. Okay. Here we have first is the definition tab. Second one is load case detail. Okay.
Yes.
In the definition, we have to define the loads which is changes according to the location or environment. Which type of loads which is changes with the location or environment? Yes, Vibhuti?
Live load, sir.
No, dear. Live load is no change with the location. Your wind load.
Yeah, wind.
And
Yes.
then temperature.
Yes, yes, temperature, your wind load, and your seismic load also.
Seismic load.
Yes. Load.
And snow load,
Yes. Snow load is also.
right?
Mm.
Okay. So, in the definition, you have to define the wind load, snow load, okay, seismic load, okay. So this is your definition for the loads, which will be changes according to location and your
Requirement.
okay, okay. So we talking about the load case details. Cases means your category, right? So you earlier said we have live load and dead load, right?
Yes.
Okay. Now click on the load case detail, right? And go to the add button. Go to add button. Here we have some load categories or load cases. So now I am taking the dead load. This is your dead load, right?
Yes.
And named as dead load. Okay. And click on the add. And click on close. So this is your dead load folder. What is this? Dead load folder means case. In the dead load, you have to apply your loads. Got it?
Yes,
Yes,
sir.
sir.
So select your dead load and go to the add button. In the load case, you have to click on the load case and go to add. Okay. Now again, select your dead load and click on add. Now we have self-fit, okay, nodal load, member load, uniform, uniform force, concentrated force, linear varying force, tripodal force, right? All types of the member loads. Okay. Okay. First, we are going to talk about self-weight.
Okay.
So you all we know self-weight is the weight of your members, right?
Yes.
Okay. So in which direction this load is applied? In which direction? X, Y, or Z?
Why?
Sure.
Yes.
Explain. Explain.
Our drawing is XZ plane.
Okay. Very good. Very good. Because we are considering that my load is applying top to down.
Vertical
Yes.
direction.
In vertical direction.
Yes.
And that's why we choose Y axis. Okay. And below this, a factor is this. What is this?
Safety factor.
Safety factor. And what was the negative sign denoted here?
Downward direction.
Yes, very good. Vibhuti,
Yes, sir.
why we assign the negative?
Due to downward direction.
Which in this?
Gravity.
Yes, Andy. Very good answer. Because we are considering that load applied in the downward direction. Okay.
Yes, sir.
So after that, you have to click on the add button. So see, my self weight is added in the dead load category. Okay. Yes.
Yes, sir.
Okay. This is the first load in your dead load, right? Now go to the member. Second load is wall load, as you said, right? So where the member where this wall load is applied? On beams?
Member.
On
Member.
beams? Beam
Yes.
members. Okay. And click on the member load. Or which type
Uniform.
of that load is uniformly distributed? You just click on the uniformly force, right? And here you see with the red color W1, right?
Yes.
It is a sample of uniformly distributed load in which on every point the amplitude or a magnitude of your load is same. Yes or no?
Yes, sir.
Here we have the W1 means the weight of your wall, right?
Yes.
What is the D1, D2 and D3?
Distance, sir.
Sorry, distance.
Distance.
Okay. What is the D1 distance?
Given distance or 1 meter, 2 meter.
See, consider this is your member. Okay. And the
Yes.
length is 4 meter. Okay. Now I am going to apply the UDL from some distance on starting is 1.5 meters. Okay.
Hmm.
So this is your D1 distance. Here your load is applied.
Radial load.
Yes.
Okay.
From how much we left from the starting, how much distance. So this is your D1. Okay.
Hmm.
What is D2? From the starting to the end here. This is your distance is D2. Yes or no? So D2, D1 is 1.5 meter here, right?
Yeah.
And this is your D2 is 4.5 meter. So what is the length of your load?
The total distance is 4 meter.
Oh, sorry. This is your 3.5. Sorry. What is the length of your load?
4.
4 meter is your length of your beam, of your member. I talking about this distance from starting load to the end load. This one.
2 meter.
2 meter.
Yes. But you specify this load from the starting. That's why it comes by the 3.5. Okay. And the remaining distance was 0.5. Okay.
Yeah.
Okay. If I applied from the starting to end, so D1 is 0. Yes or no? D1 is equal to 0 and D2 is equal to 4.
Yeah.
Yes or no? Okay.
Yes, sir.
So there is, yeah, Bhubhuti.
Repeat.
If you applied a load from starting to end,
Yes, sir.
so what is the distance of D1
0.
and D2?
4 meter.
Okay. So what about the D3? We talking about the D1, D2, and what is the D3? Acha, what is the width of your member?
300.
0.3.
0.3 meter, right? Or a
Yes.
300 mm.
Yes.
So you have to apply the load in the mid of your member. So see, the D3 is specified in this figure.
Yes.
So this is considering the width
Yes.
of your member, right?
Yes.
Yes.
So you know about the D1, D2 and D3?
Yes.
Alright. Now I am talking about the W1. What is the value of W1 for the wall?
By in whole beam, then
Density of brick
Density, yeah,
into height of the wall
yeah,
into
length of your wall
yes,
into width of your wall, right?
yes,
No, dear, no. Length into width into height is the volume.
yes.
So can we multiply with the density?
No.
No, dear.
Height of the wall
Yeah,
into
yeah.
thickness of the wall.
Sorry.
Thickness,
Acha, okay, thickness.
and then density of the brick.
Okay. Any other remaining something? Or you complete? Okay. What is the density here?
Brick density. It will be 19.
19.
Yes.
Density
Or
means
20.
if you sorry if you have the weight of your brick, if multiply by your density, what is that? What is the unit of density?
Kilogram per meter cube.
What?
Kilogram per.
Yes, dear.
Kilogram per meter cube.
Just see here. Density. This is your Newton per meter cube. Okay. It means MJ. You said
Yes, sir.
volume divided by multiply by your density, right?
Yes.
So density is 23.56. 23,561.6. It means in Newton, right? Okay. Okay. Now the value comes in the Newton after the multiplying this. Okay. Okay. Good. Very good. Right. So Newton weight is comes out by multiplying the volume of wall. Yes. Yes or no?
Yes, sir.
Okay. So what is the value of G
9.81.
and value and your unit?
It will be gravity.
He have also a value for G, gravitational force.
That value is 9.81.
Yes, a meter per
Second.
square.
Meter per second.
Square. Meter per second square. This is the acceleration due to gravity, right?
Yes.
Okay. So the second method is you find the number of bricks in your wall. Yes or no? Can you find the number of bricks in your wall? Right? Dear?
Yes, sir.
Can you able to find the number of bricks in your wall?
Number of bricks in wall.
Yes. Dinesh? You are able to find the number of bricks? No.
Explain again, sir, question.
Can you find the number of bricks in your wall? Volume of
Volume, the 1 meter.
volume of your wall is divided by
1
the
meter total size of the brick, total one brick size volume of the
one
one brick size.
volume of one brick, right?
Yeah.
All agree?
Yeah.
Yes, sir.
Okay. The number of bricks is comes. Okay. Can you multiply by the number of weight of your one brick in kg?
Your screen is slow, sir, now.
Now I'm nothing doing with the screen, dear.
Okay.
Okay. Just you find the number of bricks. Agreed?
Yeah.
Yes, sir.
Then you have a weight of your one brick.
Okay.
It comes approximately 2.5 kg for one brick. Approximately. Maybe 3 or in between 2.5 to 3. We consider as 3 kg. Okay?
Yes.
Mm.
Okay. So you can multiply with the number of bricks. Okay?
Mm.
The total weight of wall is come. You have a total weight of wall in kg. Yes or no? You have a total weight of wall in the kg. Yes or no?
Yes.
Okay. You can multiply with the G to convert into the Newton. Yes or no? Yes, MJ? Sava? Am I right or wrong?
Yes, sir.
Sava? Savanas? Okay. Dinesh, you are agree with me?
Yes, sir.
Okay. So what was the volume of my wall? The length is 3 meter. Remember?
Yes.
And the height is also 1 meter, 3 meter. Sorry. And width is 0.3 meter.
Yes.
So you can easily find the number of volume of wall, right? And you know the dimension of your one brick, length, width, and height.
19 to 19 to 90.
19 into 19. This is your cube. No, dear. It is a cuboid.
Okay.
It may be 230 if you consider a brick at as 9 inch,
Yeah.
right?
230.
230 and 115 into 115. Height and width consider as the 4.5 inch. Yes. Okay. And we have so let's find the what is the value of W1. Tell me. You have two processes. You have find the weight of your volume of wall multiply by the density. This is the one method. And second one is to find the number of bricks into the weight of one brick and multiply by G. Yes. So find the value and tell me.
Height is how much, sir?
30.
Height.
Height is 3 meters. I want answer from each one of you. Right answer? Vibhuti? Vibhuti? Yes.
Okay.
How we come this?
Density into volume.
Sorry?
Density into volume.
Yes, density into volume. So you just give, this is your Newton per meter, and you type this, right? Newton per
Yeah.
meter. But this is the only big bit, because in the 1 meter you don't have applied this much load. Okay. Okay, we considered in this the plaster weight and all other weight, like, okay, your mixture of cement and sand also considered in this way, right?
Okay. Mortar.
Yes, motor. So 0, D2 is 3, and D3 is 0.115, right? And here I am considering the GY direction. Okay. Click on add button. Close. Now we have to assign this. Assign to view, because self fit is applied on all the part of body, like this.
Yeah.
Okay. And this is applied only on the members. So you have to change your view. Click on the control button and select like this. So this is your members.
Yes.
So see, all the members is selected, and go to the assign to selected beam. Yes. And click on assign and yes. So see, by the blue color is applied on each and every member.
Yes.
Yeah.
In the uniformly distributed. Okay.
Yes, sir.
Okay. The last load in the dead load is remaining, which is the floor load or your slab load, right? Go to the select
Hello.
dead load. Yes, yes, Dinesh.
Hello, sir. Each and every floor we have to different types and different loading is there sometimes.
For the floor.
Yeah.
Okay. You can choose different type of load. First you consider about this load.
Yeah.
Okay, no problem. Go to the dead load. Select the add one. Okay, add, and go to the floor load. Okay. I just listen here. See here. Your load in the rectangular shape slab. Okay. You know what is the one way or two way?
Yes, sir.
Yeah.
Okay. So if you join your corners like this, okay. Now weight of this triangle is applied on this member, is distributed on this member. Weight of this triangle is distributed on this member, weight of this triangle is distributed on this member and weight of this triangle is distributed on this member. Yes or no?
Yes, sir.
And this is comes like this on your member in the triangular shape. Yes or no?
Yeah.
So this load slab flow load is considered into the linear varying, because starting from the zero and gradually increase up to the maximum point and gradually decrease up to the zero, like this. Okay.
Yeah.
Okay. So the area of your floor is 3 into 3. No. Yes, 3 into 3. 9 meters square.
Yeah.
So what is the value pressure of your floor? Multiply by the weight density of concrete. Okay. Oh, in the wall we did a mistake. 23 is the density of concrete. Yes. We don't.
24, sir.
24. No, 25. We consider the 25. Consider the density of concrete. Okay. So if you done your practice, you multiply with the density of brick, not the concrete. Yes. Okay, you remember that. So here you able to find the pressure by the volume of slab multiply the unit weight of concrete. Yes or no?
Yes, sir.
So here I am going to give this.
Line.
Yes or no?
Yes.
Okay. So this is only for the first floor or all the floors.
First floor.
So you give the range as 0 to 3 and X range is 0 to 12 and Z range is also the 0 to 12. Click on add button and now you see the value is too much high here up to there this point. So this is your triangle shape. See, only for consider for the
First floor.
first floor. Similarly, you can add another one floor load for the second minus this one, and the Y range is 2.5 to 6. No, not 2.5. 5 to 6. Okay.
Okay.
And X range is same 12 and 12. Yes. Click on add button. So this is only for the second floor. Yes or no? And similarly, you can third floor, fourth floor, and fifth floor. Okay.
Okay.
So this is your homework to apply.